would you go about like computing the center of an object? Because for a regular geometrically regular object, that's simple. But like, what about for a view input?
Scenic defines the center of the object to be the center of the bounding box.
The center. Oh, it's the center of the bounding box.
Yeah.
I see.
The reason for that is just it's a simple definition that works for any shape of object, right?
Right.
Now, one thing that Scenic does let you configure is which point is considered the base of the object.
Right.
So when you say, like, if I want to put this object on the table, which point goes on the surface of the table? By default, it is the center of the bottom face of the bounding box. But if it should be a different point, you can adjust that. If you have an object with like a weird shape, like, some like stocking, which is hanging over the side, right? You want this part to be something like that. But we didn't want, so this is related to the topic of today's meeting, I guess. One thing that we didn't want to get into was having Scenic basically have to simulate contact physics or something like that so that you could, for some arbitrary shape, exactly put it just tangent to the surface, right? And that is potentially a problem if you wanted to say things like we have some irregular surface and now you want to position a bunch of objects on that. But Scenic does the simplistic thing of putting the bottom of the bounding box of each object on the surface. So part of it might actually flip into the surface. But Scenic does not attempt to figure out what would be the stable position for it at that point, right? I think there are libraries which can do that kind of thing. But Scenic doesn't use them.
Right. Yeah. Because the reason I was asking is because in robotics simulators, what often happens is that for example, when you import the URDF, right? Yeah. And the URDF itself actually specifies a particular coordinate frame, saying like this is where actually the base should be, and this is where you should reference the base. Right. And oftentimes it's kind of hard for you to for a person to tell, oh, what is the transfer from the base frame specified in URDF to the center of the bounding box? And especially given that a robot, which is constantly moving, so the bounding box should be changing dynamically. It's kind of hard to figure it out. And now that inside Scenic, since we've incorporated the sensor feature, which is specified relative to different parts of a particular robot, that actually kind of becomes hard to figure out what to actually tell Scenic.
Right. I guess it's not something that we really have thought about so much right now. I mean, since Scenic doesn't have a notion of compound objects or anything like that, we just have the center, which is fixed, and this base point. Those are the only two things which are customizable.
I guess, I see. It's just that I was wondering whether it'd be possible, but because at least when I was thinking about it, really, like maybe like for different objects, you can specify where you should what point you should use to refer to its location.
Right. So we did actually think about that. So maybe we should really try to get more in a bit of a circle here or something. It's not like I'm going to be the one talking. So maybe you all can stay there. Maybe if you just want to flip around yours.
Sure.
So there's nobody on Zoom right now, so I'll leave it open just in case. I think we did consider like having a way to customize which point is considered the center. It just seemed like it just added additional complications. Because if you wanted to basically all of the center of the object is used for is like the position property that we send to the simulator.
Right.
And if you record the position of something to get a trajectory, it's that point which is used. And so you could always just, if you wanted a different point, you could just post-process that basically to get the point that you actually want. Whereas no other Scenic syntax really uses it for positioning things. Like on uses the base point, which you can customize. Right. And so we thought that adding like another level of indirection, like the center is no longer the center of the bounding box, but it's some arbitrary point that can be changed on a per object basis, just seemed like an unnecessary complication. But maybe if there are cases where that would be really helpful in modeling, making it easier to model things, that would be good for us to know about because we could add that.
Because the notes is that, of course, there are a few things like this. Well, the first idea is just that, it would be great to such that, the Scenic coordinate system is sort of close to what people want to use in a simulator as possible. And in robotic simulators, the coordinate system can really get changed pretty wildly from robot model to robot model.
Right.
And then it kind of becomes hard for the programmer to actually write a Scenic reason about the Scenic program as to, way they should define things. But another thing is that if, the different, if you're able to more dynamically specify, I guess, especially when you're starting to reason about compound object, the way URDFs or specify specify a different frame for each link of the robot, say a robot arm. But oftentimes those are also not necessarily in the bounding block standard. And then in that case, you have to have like a completely different set of transforms, I guess, even.
Right. I mean, I think like ultimately there's no way for Scenic to pick like the right coordinate system.
Right.
So there has to be a global coordinate system. Right. And what we can do is make it easy to use local coordinate systems. So like what you were suggesting before, being able to import a URDF file and create local coordinate systems for each of the links and with names so that people could then refer to them seems like a clear thing that we should do.
Okay.
And I think Scenic already has operators to make it pretty easy to work in those kind of coordinate frames because you can basically use this relative to operators.
Right.
So you can say if you want something at 1, 2, 3 in the global coordinate system, you just say it's at 1, 2, 3. If you wanted 1, 2, 3 in the coordinate system of this particular link, you say 1, 2, 3 relative to link 5.
I see.
So yeah, I think the difficult part there would basically just be importing things from URDF and making those available conveniently to the user. Right. I don't think we would necessarily need to do like change the language or anything.
Okay.
But yeah, but it's good. It's a good point that like this might be a nice source of examples where you need to work in a lot of different coordinate systems at once, which we haven't had to do too much before. Before we had a few like local coordinates versus relative to a particular car, for example.
Right.
But not usually when talking about a single object, you have like many different coordinate systems for different parts.
Right.
So the point of this meeting is basically to talk about what should we do in Scenic to help robotic applications. People who might want to use Scenic, how can we make it most useful? How can we make Scenic most useful in these kinds of applications? What's different about robotic applications, say, like what you were just saying, from some of the other ones that we've already done a lot of work in Scenic, because much of the language design effort went into making those driving scenarios reasonable. And it's possible that there are things you would like to do for other applications, not just robotics, but any other applications that are kind of awkward to do right now. Maybe we made some assumption which is not reasonable, like this assumption that objects are single units, right? Was fine for cars, doesn't really make sense for robots. So are there other things like that, right? Or are there other features that we should prioritize working on, things we could do to make Scenic more helpful to people working in domains other than autonomous driving, since this is now the robotics and everything else meeting. Open the floor.
The structured time step thing was good.
So
like the thinking this step through every time step.
Oh, the incremental thing?
Yeah.
Right. So that we definitely have on the list already. So that we have done for sure.
For the physical simulation part, I actually don't think Scenic should be the right layer for the physical. I agree with you on that. But then the problem is, like you said, if I place some weird objects on the run, how do I deal with the certainty when I actually do use those physical simulators when I actually take it start? Right? Like, I can use Scenic to set up the scene. Maybe there are certain things need to be fixed with putting things under a table, this one of those stuff. But let's just say that can be fixed. Then how do you actually give certainty that you actually also use Scenic to put it into a physical simulator and then start to simulate that down.
So you mean like certainty in
like, like this weird shape, you put it on the table.
Right.
Depending on how you initialize it, it's probably, things also bump into each other.
Right.
Yeah, I've got this things where, for example, random bin picking, when you generate data, you just have like 200 objects hanging on top of the bin or something, and the initial of the simulation, everything drops. So that's the randomness of this sort of application
Right.
data. But then but then that's kind of against kind of the probabilistic, thinking of the language.
Right, I see. So because you don't in that kind of setup, you don't actually know what the final configuration. Once things have settled down, where they'll end up. This is what you're saying.
Yeah. And then in that particular case, the more chaotic, the better, because you want to generate the right data. But then there are cases where you actually want to.
I see. Right.
Yeah.
So like either if you do it in that kind of approach of drop a bunch of things down and let the simulation figure out what the stable configuration is.
Right.
Or if you want to do the scenic way where we're saying what the configuration should be, then you end up with unphysical things like the cup is clipping into the surface or something like that.
Right. I assume clipping into it, you can probably fix.
I mean, maybe we can detect that at least and say, let's throw this one out, right?
Right.
But it might not be the ideal position.
Yeah, but what if you have like some shape that's like kind of upside down and this thing actually falls?
Right.
Right. Then it's compact physics.
I see. Right. So it's like you think you've written a scenario where this thing is positioned like this, but actually as soon as you start the simulation, it falls over, and so the robot interacts with it in a totally different.
And specifically, the way it falls over, even when you do have a physical simulation, likely it's not deterministic.
Okay.
So, and then the contact physics of grasping to an object, that's definitely not deterministic.
Okay.
So those kinds of things. But it is important to be able to simulate that correct, the right way so that your grasping objects will be able to tolerate, you'll be able to kind of grasping skills. I'm not sure.
Just to clarify, you were saying, are you talking with respect to like humanoid?
Oh, just any objects. Any robot with manipulator, right? I mostly work with manipulators in my career, or maybe more like working planning.
I see.
Whereas, give you an example, if you actually push your cup through the surface, this is a very classic problem in robotics. It's just going to be completely random. Every time you do this, it's not the same. How to take that kind of surface kind of randomness into a kind of program approach.
Right. Yeah, that is a good direction for us to think about, because it's not something we've really considered before. The closest thing we had is that sometimes, like in Carla, for example, it will refuse to create an object because it would actually clip into something, right? Because we didn't know about the existence of some obstacle. So we put the car here and it actually clips, and Scenic, Carla says we can't do it. And then that will cause Scenic these days to just throw it out and try again, right? But it would be better if we could understand why it didn't work and, adjust it or something like that.
I mean, sort of, robotics is probably used like Majoko's pipe bullet for those simulations. Maybe like NVIDIA's, whether physics engine. Yeah, there's like a PhysX back in the day, right? It's kind of saying to use it for those things. I can see it perfectly well using language like Scenic, because those simulators can be pretty tricky when you start building up like more complicated things. And then on the other side, this contact physics, they were actually way more accurate than, like car.
Right.
So how do you do that?
Right. Okay. Yeah. Thanks. That's a good direction for us to think about. Yeah. I'm not sure offhand. I mean, it seems like potentially there are ways Scenic could help with that, because it does talk about distributions. So you could imagine having some kind of distribution saying like, well, we're not sure we're going to be able to position the object exactly like this. So we actually have some distribution on how it might end up being oriented, right?
Exactly. So so long you have like an interface for the feedback on the results of the distribution, like this verify, and then that's also very good. Have access to that. But I don't know if any of your simulators that directly supports physics, like your supported simulators. Is there any?
None of them are, well, so Weebots, actually, I'm not sure how good the physics in Weebots is.
I thought it was.
It does some.
Yeah,
I mean,
does some.
they have examples of, robot arms, which manipulators that are picking things up. And so it can do that to some extent. I don't know how good it is compared to, Mujoko or Pygol or anything, because I just haven't used, I don't know, it's not my area, so I don't actually know how good these different ones are. But certainly, yeah, it's not an emphasis in Carla, which is based on a game engine, right? So it has, it does collision detection, but nothing very sophisticated.
Well, gazebo and habitat will have physics.
Yeah, right.
The gazebo physics is pretty janky. It's not.
Weebots is too. I mean, we've had problems with Weebots. Like we had actually, I forgot to show it this morning in my talk, but we did a case study where we had these little paper bots. They were made out of folded paper. It's this group, Ankur Mehta's group at UCLA has these easy to construct robots that you fold out of paper. And basically, we had some problem for them where they're trying to go over some kind of pyramids. Like there were a couple of low down pyramids and it's trying to drive over them. And we were doing design space exploration. So searching for different width and length and size of wheels for these paper bots to see which ones were able to climb over these pyramids the best. Because some of them, they can't get up in the first place. Some of them, they get on top and then they flip over when they start going down, etc. And so there we were doing this in Weebot. And we saw all kinds of bizarre artifacts that made the results very difficult to interpret. Like the robot is going up the pyramid and it, flips over, gets stuck between those, and then like starts bouncing, and it just eventually flies off into space. It's like, what happened to conservation of energy? It just flew off from nothing. So yeah, that's obviously a problem with the simulator. It doesn't have good fidelity physics. But yeah, it's just something we haven't really worried about too much from the Scenic side because it's just orthogonal to us, right? We're like setting up the simulation, and we're depending entirely on the simulator to actually do the physics.
Mhm.
Yeah. So there's no reason why you couldn't interface Scenic to a simulator that does a lot of work to try to do very accurate physics. But then there is the problem you mentioned of the scene you set up may not actually be feasible, or it may immediately fall apart in a way you didn't expect. And so then your scenario doesn't really do what you thought it.
You can turn off gravity.
Gravity.
Oh yeah.
Although physics engines are, you can set the random seed though, right? So they are still deterministic. Yeah. So I guess maybe then you're not directly specifying the stable configuration of Scenic, but you're just saying, I just tell Scenic to do this. It's going to generate this series of stable configuration that's going to, after everything rolls and falls in place, and then these cause problems. And then you can probably just abstract away the physics maybe as part of the random process or just part of like the simulated ethics.
I guess Scenic can just initialize it.
Yeah. And then you just consider what happens there next with physics as part of the simulation process.
I mean, we have this problem to a lesser extent, even in some of the things we've already looked at, like in the Carla interface, actually, if I remember correctly, we actually allow a very small amount of time to pass before we start running the simulation, because the cars usually get created slightly above the ground, and you have to let them fall onto the surface. And I think the reason that Carla creates them above the ground is so that they don't clip. And then it lets the physics engine figure out, okay, let's make it tangent. So but what that means is what you wrote for the initial XYZ position is not actually the initial position, because a couple of time steps elapse and it will fall down. But this problem would be much worse if you have, objects that can follow.
Yeah, it's kind of gazebo too. And actually, when you're writing a senior program, because we don't know the exact height and length of everything, we just kind of have to. When we're spawning things like robots, we kind of have to put a little bit of offset. Because otherwise, if it clips, the entire simulation just breaks down.
Mm-hmm.
That's kind of robots you're dealing with. You mentioned about the one with manipulators. What are other robots that you
I do mostly drones.
drones? Drones. Oh, I see. Hey, so which kind of gets the question of, or Mary, do you also deal with
Yeah,
which kind of robot?
drones.
Drones.
Yeah, that's the one.
I see. I guess so. What I'm trying to ask is, let's say the manipulator ones are primarily used in the indoor setting.
Are you like, sorry, are you doing like mobile manipulators or static manipulators?
Yes.
The robot arms?
I want to say static, but then I actually did some both stuff too, right? So I say mostly stuff.
I'm trying to understand, like, I think it depends on which robot we're talking about. But for example, if it's like a humanoid for the indoor setting, I'm not really sure what is a good. Like, I'm just trying to understand which type of robots should we be targeting using Scenic, to really maximize its strength. In case of like indoor humanoid or things like that. Like, so where is Scenic, like what is Scenic like strengthening? I think from my personal perspective, it's defining the multi-agent kind of reactive scenarios. Like the ones you saw in the cars or, like for example, ego agents may interact with pedestrians, cars, bicyclists, right? Defining that reactive behavioral interactions, which also comes at variations, right? When it comes to humanoid, I think, for example, it's just at its inception of being able to do basic tasks that, I mean, even trying to bring in this interactive multi-agent setting seems like an overkill like that humanoid is not prepared for. And my question is, if you do provide that kind of support, would the community even need it? So then my question is maybe drones, which are outdoor, probably interacting, that may have more, like, but if it's drone, then what kind of scenario would it be so useful? If it's just simple reconnaissance kind of thing, it's like randomizing the locations and so on. Not sure whether it's any, I mean, it can be used, but not like maximizing functionality. So do you have any suggestions as to, like, with respect to the robots that you're dealing with, perhaps these kind of scenarios or this kind of application domains see videos before?
Sure that the drone people especially.
Yeah.
I guess for what we are trying to do, yes, you're right. Like reconnaissance, things like that. Like if we're just looking at a scene, if we're just looking at something, we're just using this drone to just fly over and this thing, maybe it's not like this. I want to say not useful, but it's like not maybe the right thing to do. But to your point about reactiveness and all of these examples of the car, the car stopping because of a bad little part, like the car that drives out into the street. For us over at DC, what we're trying to understand a little bit more is maybe this reaction from the drone to the scene that it's looking at, in the sense that, let's say, for example, you want to land somewhere that's maybe an urban environment, and you don't want to land on top of someone's head. That's bad. And so, in this scenario, we have a pre-designated landing site that it's not maybe blocked off to the public, and you have people, kids, cars that may be intersected at any point. And our hope is that this drone would react in maybe some kind of way to either avoid it or stop itself from going until it's clear. So in that way, that's I guess the reactiveness in our use case comes from that. So I'm still new to, I came here to learn about Scenic, I'm still new to it, especially this, in this type of application. So maybe in the end, it is maybe overkill to use Scenic for this kind of task, but I just wanted to come
I think that one makes perfect sense. In fact, there was one that I don't know if any of the folks at Berkeley ended up actually doing this, but the taxinet example that Sandra showed, there was supposed to be a follow-up challenge problem where there it was the simple like follow the center line. But then there was also a challenge problem also from Boeing, which was basically a plane is approaching an airport and has to make a decision of whether to land or not. And then there could be stuff going on at the airport, like other planes, trucks, whatever. And so it was similar to the one you just described. You have to decide, like, should we land?
Right.
Should we go for a circle? Land on a different runway? Whatever. But I don't know if anyone actually ended up using Scenic for that. Do you know Eddie? I'm not sure. That was proposed as a challenge problem at some point, but I don't know if it ever ended up happening. But anyway, the plan was we could use Scenic to describe the possible behaviors of what's going on at the airport. So I think that makes a lot of sense.
Yeah.
From the arm perspective, I want to clarify arm because human domains just some different it's a group, right? I think for example, cleaning up a table, and then a lot of the motion planning I want to do, and then we have something where we active motion to the 7 dot parts. So they're not static. Right? They're kind of like drones, except we have context. There's the articular and then we have context with the table, we can have context with all the things you put in the scene on the table. And then the way I see it is that if you have like a manufacturing work cell that is shared with a human, or have multiple arms that is on the same work shelf, how do they actually coordinate with each other? And then how do they clean up the table? How do they perform? So it's in manipulation, it's very task driven. So what kind of different tasks can you do?
That's interesting. It's especially in the factory setting.
Yeah.
I'm aware that there is increasingly more collaboration between robots and humans.
Yeah.
But so I can see what you're saying. Do you happen to know like any particular scenarios that we can reference, like that are realistically like like how would what kind of tasks are we talking about with humans and robots? Because I vaguely heard about this. I've never had a chance to completely
So
look at
the
it.
funny part is actually probably a little bit more to the car topic. So EV charging robot. It's just very clear.
EV charging robot and figuring out where to plug in.
How to plug it in, there's people around, right? And then you may even need to coordinate with the car. Even that. I mean, like, but that's the most straightforward thing I can think of, right? But if you're talking about like within manufacturer, like for example, warehouse logistics, how to Amazon's kind of use case, how to store things. Kind of there's a robot, and then a lot of times
How to store things?
how to like there's a shelf, and then the vendor have like stuff you want to put it. Well, actually, how do you store? Meaning like this mix of things. You want to take this object out and then put it into a specific designated shelves.
Okay.
Right, like the boxes.
Yeah.
And then now this is kind of semi replaced by the robot now. Even with the all kinds of things low, right? But there's still people that are in warehouses. People runs around warehouses, that. And there's also a particular kind of task called stowing. So imagine there's a mobile robot that will come into a station where you have like a big space stationary robot that would actually pick up things from the assembly line and load it onto the mobile robot. And you can imagine this kind of warehouse logistics solution. People run around, people control the robot. It actually, and then the load can be different. Like even shape wise, they're not even just like weight wise, they're different. Like shape, they can be.
That's called stowing?
It's called stowing, yeah.
It's kind of like, you're essentially running like a DEX net. on the robot and try to do this kind of robot.
There's segments. There's the sorting as kind of
Right.
pick and place is sort of the thing.
Yeah,
right?
yeah.
But there's also things like what they call palletizing.
Palletized?
Yeah, loading and unloading. These are actually all new topics in logistics. That's like you need large robot arms, but also together with either a vehicle or a mobile robot. The mobile robot part is already very similar because in the warehouse kind of scenario, they're quite different from traditional industrial environment where people unload a lot. The warehouse, people run in those spaces. You may have lines where people run through, but they like the robot also share those things with people too. So there's things.
I wanted to ask about these problems because we thought about using Scenic for like a warehouse robotics kind of application, and we looked to see like could we find any simulations people had already made of this kind of environment, and we really couldn't find much.
Very tedious to even deal with those.
So I'm wondering, for any of these kind of tasks, are there like simulations that people have built already that are available?
The gazebo, Isaacson, and then actually Unity background is still really active to develop this robotic simulations things. They have scenario, they have backgrounds. I know Isaacson is probably still in active development. Gazebo, I feel like someone just made it and put it there. I'm not quite sure if it's maintained. Unity, I think they did that.
So like the one in Gazebo, so it's like some kind of assembly line thing?
Not assembly line, it's a warehouse, like an Amazon warehouse, or like the back, like the back room of IKEA, that kind of.
Okay, so I haven't seen that one, and is there software that you can use for the planning?
You can generate a scenario, but
I mean, for the actual robot, like we need a system to test,
I recall,
right? Available.
Well, Gazebo have a lot of
I
People it's a lost too, so there's an entire navigation step attached.
Yeah, I think there's like a small, almost turtle ball looking thing that, if I recall this right, they had the software stack. But yeah, I think it does run on the newer version of Gazebo. And then but I think the most complete one might actually be I'm not quite sure how much it is maintained, but the more complete one I think is probably on Isaacson.
Okay.
But I think Omniverse now probably
really
those things. I think I've seen something. I haven't really tried that since.
What's the difference between Isaacson and Omniverse? I did the same.
Yeah, why do they name it those? I saw Omniverse.
NVIDIA?
They're both NVIDIA. Isaacson just has been around for maybe 4 or 5 years.
I mean, might be emphasis is different. I don't.
Are they different simulators? Or
I don't know why they have
different names.
Isaacson somehow it's actually more integrated with the robot controller as well, precise simulation.
Yeah.
I think the Omniverse, I'm not sure. It's a couple months ago, it's all about this like Metaverse.
Yeah.
So
yeah. Isaacson also does have human models, I think.
Yeah.
Like actually humans. I'm not quite sure if Omniverse has it. Yesterday I was actually talking to a neighbor over there, and he said that if you're a researcher, you can actually get access to Isaacson without having to pay a fee or something like that. At least according to him. And also in terms of the robot arm scenario, another simulator that comes to mind. I'm not quite sure about factory settings, but another robot that actually the simulator that comes to mind is actually a Dorsa recommended us a while ago.
And what's it called?
Called RoboSuite. Suite has a hotel suite.
robot speed.
Yeah, and that one seems to be very ARM focused. Like all the robot models that's natively ported in there are robot arms.
The stuff they're saying.
Because I think like when we were looking for potential case studies before, we found some examples where people had mocked up things like this. So like Weebots has an assembly line thing with an arm from can't remember the name of the company.
Kuka?
Like
Lawyer?
No, it's not a mobile. It's a fixed arm.
Yeah.
But maybe it's the Ceramic. Those two. I don't know. I can't remember it offhand, but they have several arms from this company. I mean, Weebots has a bunch of robots built into it.
Yeah.
So they have this thing where there are some blocks coming down a conveyor belt and it's picking them up and transferring them somewhere else. And then we're like, oh, great. We'll use Scenic to randomly position things on the belt, do some interesting thing there. And then we look at the code that's picking up the things and moving it, and they hard coded it. It's like,
it's
grass for this amount of time, move over here for this amount of time, etc. So it's not actually doing planning, perception, anything.
Well,
right?
because
So that's why we're wondering, like, if there are examples out there where people have put like a reasonable stack and is actually doing planning at least, right?
Yeah, in terms of stack wise, gazebo for gazebo simulation, for example, the Sawyer one we did for the example implementation, that has the full stack in. The problem with that one is that with gazebo in general is that running multiple agents, multiple robots in there is a system like it just
That's,
couldn't
but
really
even
take
a
that.
single one, I mean, you can do interesting things.
Yeah.
Like the one you did, the examples you showed, right?
Yeah, and that one has the stack as a
Okay.
reasonable stack. And if I recall, and I think maybe the Kuka Panda has a stack somewhere. The white one actually you guys are using Weebot. I think it is that model, the Kuka Panda.
I want to show, so I showed Sanjay this morning on this one. He was kind of interested, but this is what they have. They have this Panda robot. Then this is VR.
Oh, yeah, the Panda, that does look like, okay.
And then this is Unity kind of HoloLens virtual reality thing. And the motion planning is reactive. And then the point is that you can kind of manipulate the robot as if you were playing in a game.
Yeah,
Whereas the robot is reactively
This is what we want to do.
yeah, that's what we wanted to do. So
And which simulation environment is this again?
Oh, it's not simulation.
Oh,
This is essentially Unity. We build the app.
yeah.
Okay.
Where'd you? And
So it's just rendering, right?
okay. Where did you get so does Unity? So I know Unity has a ROS bridge that you can essentially run ROS there. Are you running ROS?
This is running loss. This was 2 years ago. This was ROS 1. Now we all migrate up to ROS.
Okay. So
But are you still using Unity?
Not specifically. The Unity, this is the kind of, because we were working with HoloLens, right? We were going there. So, this is more like, it's not simulation. It's more like for teleoperation interface.
yeah, like it's kind of circling right here.
But if you look very far behind on the other side, like the computer that actually controls the robot, I don't know if you can see it. It's like, so that one did have like a simulator. So on the far side, there's another computer that one actually run the eye sensing
I see.
on the back in the cloud supposedly. So it's just this is just the AR interface, and there is actually a physical simulator that runs the motion controller for that.
Oh, so you're doing it in IDEX and it's just a Unity front end for rendering it in beyond.
Not even. Yeah, for rendering for the user,
Yeah, but the actual simulation of the robot, all the stats not running, but it's running IDEX and something.
Yeah.
Oh,
Yeah, everything was connected through ROS, right?
Okay, that makes sense.
And then, like all different things, Windows runs on HoloLens, the motion controller runs in the cloud, that's on Linux. They're connected through ROS. That's what's kind of stuff.
It's kind of like what the Habitat folks wanted to do. The Habitat folks, what they did is that they essentially had this infrastructure where you can run a simulation in their thing, but you can also have they also have the VR community front end where you can render the whole thing in VR. But the simulation has to be run in their simulator. Right. So that has conflict.
I think so what you're showing us is what we at some point wanted to do. But at the same time, I think the tricky part was, especially in Unity, are we importing these assets?
You don't want you, frankly, I don't want you. I just want some kind of interface I can go on with, for example, Omniverse, and then do something. I think I mentioned this, like Sandra saw this video, right? He was interested in this joint collaboration of the human collaborate with the robot, and the brain is the robot.
Like the setup that we were thinking about and why Unity we find to be useful is that if it's an AR setup, then we can test human robot interaction safely.
Yeah.
Right. And then still generate various scenarios using Scenic to try to search for failure scenarios.
I see. Yeah, that's really good point.
But the downside is that, like, how do we, like, where are these assets? And then do they work? And like, what if, so let's say you have a particular robot.
Yeah.
And you want to test that robot, not the traditional type that is already in test. So if I want to import that in, is that easy?
How do you like your idea?
Yeah. It's just that, when we're trying to use Unity, we were we looked into, the support for importing, for the URDF importer of Unity, as well as, the ROS C# interface essentially they have for running stuff in Unity. But the problem that we had was that we didn't have any robot that we can port to Unity while still maintaining its function.
Yeah.
Any robot that we have, we can only port in the URDF, but they will just be a bunch of meshes. We don't have the software stack to actually control the whole thing inside of Unity, because we didn't have it was the infrastructure that bottlenecked us.
For us, we can do this. We have reactive planning, and then we can probably do it in simulation in Omniverse now, probably. We can probably do that and control it on the robot. We have the physical setup as well. And then for us, I mean, if we had something like Scenic, like what you described, and then the way you're saying, like verify the failure scenario, the actual use case,
Yeah.
would have been like a very cool research, but it just didn't have any of that. It's just,
Would it still be would you still be open to that?
I'm open to.
Yeah, I think this would be a really good collaboration.
It will be.
But does Omniverse support like AR/VR Scenic or not? Yeah, that's the thing, right? What is nice about AR is that human can actually immerse into it and interact with it, which is
They call it Omniverse, and then it was out of the. Do you use AR or do you use VR?
we prefer AR.
So it would be full of this.
Oh, also, for example, we use MetaQuest 3.
Okay. Because there's a password. That means the VR. Seeing a flaw here is saying a short description of how to start this MetaQuest 3 VR headset and you did on your first home. See what.
Also, they do support that.
But I'm not sure if this is a flaw. So
It's not 23, it's not so far away. December 2000.
Oh, that's when we started. That's when we moved to Habitat.
how does Habitat actually support VR?
VR, yeah.
It has a VR. We haven't tried it. And we're not. It was only released a few months ago, so we're not sure how mature it actually is. But it's on there.
So for us, we actually have direction as well.
Oh, sure. Yeah. It's like this very skinny thing.
You have to remember, we haven't really been utilizing it. I think maybe it's just commonly for the iPlus submission, we probably do some people for it. But then the Habitat actually has the stretch robot in Habitat. So that robot, the issue with that robot is, so the turning, so this other robot, 70 of freedom robot, you have over the turning, so you can navigate stress. But for that robot, in order to turn, it's a separate actuator from the robot.
Oh, really?
Right? So because it's a vacuum, so you just turn this thing.
Oh,
vacuum.
yeah.
They didn't bother adding in other
Wheels.
right? So it turned out to be quite a bit of a problem because for a traditional arm robot, you just do motion planning. But with this one, it's kind of in between navigation and right? It depends on the surface how much you turn.
Right.
That part is
Right.
But that could also be interesting because that would be natural. Habitat plus that robot is already in Habitat and we want to start something by function.
Yeah. And you have the sex for controlling it already.
According to encompass the robot, I'm describing the problem where even with the control stack, it's like you want the robot to turn this way, right? With this arm, you just ask the joint to turn this way. But with that robot, it's like depend on the surface, how far it will turn. This actually may be a good thing to test the verification thing because different surfaces, the way how much you turn, you will get into the designation. It depends on the surface, but then you have presentation, distributed something like that. Yeah, should be pretty good.
Yeah,
Because
yeah. I think from our point of view, I think our interest was, well, I mean, the notion of autonomy.
Yeah.
Comes with the expectation nowadays, like almost like societal expectation that these autonomous agents can interact with humans.
right.
But then how do we even test that safety in the first place? And then so we're thinking about, oh, well, we have capability to generate various scenarios. And if you combine them with AR and have actual humans being immersed in the environment to interact with virtual robots, that we thought probably that is what the market would need in the not so distant future.
Very, yeah. We have so Bosch makes a product of active shuttle, so it's like a joystick robot. And then this spring, we just did a project how to offload the gesture control into the cloud, this sort of a thing. That could also be done. Because then we have perceptions that's just people tracking, even to the skeleton level, right? And then you want to do the interaction. The only thing about that robot is that robot doesn't have a arm. If you really want to interact with human, it's an arm, then maybe stretch or even just.
Well, it doesn't, you don't have to limit ourselves to doing arm. As long as we can come up with a realistic task that robot interacts with human in a certain way to achieve certain tasks.
Hey, how about this? It's like a robot, like an arm robot, join the kind of assisted human to lift the load out of the something like that, right? Like, so this is kind of.
So that's a good task.
Those kind of things. I think that'd be great. I mean, now the question is, do you have a simulator that supports AR or VR
That can also help.
that can, help us construct scenarios?
I mean, I feel like okay, so Habitat, I guess it's not the industrial simulator, but then if it's a robotic,
It's for smaller research, but the thing about Habitat is that it doesn't have really any raw support now. It doesn't have raw support.
Oh.
Doesn't really have much raw support. So I guess maybe if you just have the raw stack running, computing, I guess you might be able to get around it by like what you did in that video where you have the raw stack actually running the robot in one simulation, but then you just send over the joint angles to the other simulation and then you finally render it.
Yeah. Let me search around. I mean, like, I feel like Habitat, I guess is more of a mobile robot, right? Yes, it's simulator.
No, they do Panda, Kuka, and everything. They do Lotus.
Spot.
Yeah, they do. Yeah, they have. Well, Spot is a mobile robot.
And with an arm.
With an arm, but yeah, but no, I think they built it in mind where you can do arms too. Yeah, they want to. Yeah, no, you can do arms too. And so far, I think, even though I think so far the research paper they published are for domestic scenarios, but just what they have inside the simulator should be also good for a industrial scenario.
But the kind of things that they support, let's say with Spot, like the dog level thing.
Yeah.
It's very simple. Like if you ask, provides API, and you give this object to human, then it will just place it in the ground kind of thing. You don't get to like.
It doesn't have the raw test. It doesn't have inverse kinematics. It doesn't have IK. It doesn't have even SK.
It doesn't have those.
No.
But then it's simulator.
It just has to be the simulator itself. I mean, I guess because the main reason is because of the robot models we have are proprietary software. I guess because
But wouldn't it be cool because Scenic technically is supposed to be across different platforms, so you can apply to a simulator that is just VR, and then the other simulator can be anything that the system is support.
Oh yeah.
Right?
So wait.
The just question is which simulator to do the motion control, right? And then
Yeah.
Because
So
all
you
you have to do is pass the motion.
yeah. So what he is trying to say is that what we can do with Scenic is that we will have two simulators running in parallel. And one simulator that actually has the raw stat, one simulator has the raw stat that actually does all the robotics related computation. And then after it does the compute, because all we need to do to move the robot is just a set of joint angles. It's just to have a set of joint angles where like a trajectory of joint angles.
Yeah.
And then we just just send the joint angles to the other simulator live.
Contact physics, so like collision checks.
Oh yeah, collision checks, of course, collisions, given that collision checks. But in general, like the most variable things all we need to send to the other simulator is just all the joint angles the robot arm needs to be at. So essentially, you just have two simulators running in parallel.
And the other simulation is
One's-
outputting the input control.
Yeah, all the
rotor.
one
And that's
simulator.
what you're sending back.
So yeah, because
It's almost like a cloud robotics.
almost
It is called-
basically like a cloud robotics thing.
And the
Yeah.
cloud is running another simulation.
One thing just does the rendering and the actual scene.
Yeah.
Yeah, and the other one just controls the robot.
Yeah, it's too complicated for what it is. But if you can find a simulator like that, they can do most of it.
So what about omnivores? I guess it seems like or items in one of them.
Just we never really run VR in Omniverse, but I think it's Omniverse. They cannot run without the resources.
So, I mean, we can check it out.
Yeah, okay, yeah.
Yeah. You have a multiple Quest 3 headsets perfectly. And,
Yeah.
So we can,
But you got game programmers and this kind of people who's into VR. Because this particular project, what happened was we have an other human computer interface kind of a project that was running in parallel that summer. So this intern was really good with Unity. I was like, you know what? For the last week or 2 weeks, can you build me like a global thing? And then he did it
in Unity.
in Unity. So he did
That's the
he
demo.
did the front end part. Back end was Michael who actually together with me we got this reactive motion pattern.
Yeah. No, we have multiple.
We have a bunch.
In fact, I have students who are from the exact
We should head over.
who are all about these kind of stuff.